Hi everybody, this is Group A and this is our IoT project SmartParking. Here there is the diagram of use case. For our project we decided to use Docker Desktop to enhance a standalone, portable, scalable and efficient application in all its microservices. To do so we created 10 containers. First we have the InfluxDB container used to write points on the database via adapter. Then we have the catalog, which provides information about endpoints of all the devices, resources and services in the platform. The adapter instead is used to insert sensor data or statistics on databases or to retrieve them. As we can see, as soon as a new service starts running, it gets registered as a service in the catalog JSON file. Entrance and exit are used to mimic the action performed by non-registered users in our parking. The device connectors, one for parking, provide information about the status of the slots in the parking area, working as a MQTT publisher for SNML messages. As we can see, now the catalog JSON file has been modifying, carrying now, among the others, the information on all devices, users, services and parking updated. So all these containers use REST web service only for the registration of new devices, users, parkings or services, while we use MQTT via message broker for the updates. Inside the device connectors there is a class used for the simulation of cars entering and exiting our parkings. This was felt necessary to prove the quality of our project and to have data to compute the statistics. The simulation is a queue-based algorithm gathered in a loop, which first computes the actual state of the parking, then tries to handle departures, but only if cars have been parked for 30 minutes or an hour depending on the hour, and with a probability of 10%. In case of a departure, the state of the sensor changes and an MQTT message is sent to the adapter, so that a new entry in the database for the statistics is inserted with the duration, the fee and the booking code. After a refresh of the parking state, a new arrival is scheduled between 2 and 7 minutes at daytime and between 7.5 and 15 minutes during nighttime, but only if there are still at least 2 free slots. Finally, when the current time is greater than the scheduled arrival time of the first car in the queue, it gets routed in the best parking slot, which follows a balancing algorithm that tries to occupy first all the floor for the 80% of their capability to avoid the stress of the research. This triggers an MQTT message being sent to the adapter so that a new entry is put in the database of the device's status with the new state on the corresponding sensor.
Okay, now we are going to start another service, the reservation, and we try to add another device connector to our system to see how the platform is scalable with more device connectors, so with different parkings that can be located in different cities or in different areas of a city. Okay, we see now how the new sensor slots of the new device connector are being added to the resource catalog with an incremental identifier and a different location, like you can see in this screen. We also notice that also the service is now in the list of the service in the service catalog. Okay, we are starting now another service, the tab slot service. Generally, it provides for the selected parking the real-time occupancy, so how many free or occupied slots are in the parking and also exactly which slots. This service can be connected with a monitor in the entrance of the parking. The tab slots is a subscriber which intercepts all the message that the device connector publishes when the sensor slot changes its status. Okay, we are going to see the parking bot. It can be used by all users that want to park in a smart way. Before starting a conversation, the parking bot asks you which parking do you want to use, contacting the catalog to know how many parkings there are in the system. This through a post request to the catalog.
Okay, now the user from the bot menu can register in the system to enter and exit more easily. By providing his name, for example Mario, his surname, for example Rossi, and an ID card number of 4 letters and 5 numbers, and a credit card number of 16 numbers, we can see that to the user is assigned a unique number linked to a card, which allows him to exit with payments automatically deducted from his credit card. And now the user appears in the catalog JSON file. After logging in, the user gains access to 2 additional features, as we can see after the login, that are the statistics and the wallet. Next, we proceed to book a parking slot. In this case, the system suggests slot number 2 on floor 2 and provides a booking code which can be used if the user does not yet have a card. We can check in settingstatus.json that the slot status has changed from the status free to the status reserved after the reservation. From this image, we see that after booking, the Telegram bot sends a post request to the system via the message broker, updating the parking status and synchronizing the catalog and the device. Finally, we see the screen installed in each parking lot. During the initial setup, asks us to select the parking lot, and we choose parking lot 1, and we enter the user booking code to enter in the parking. We can verify from the terminal of entrance that the post request reaches the entrance for slot P22, and also we can verify that the slot status in settingstatus.json is now updated from reserved to occupied.
Now we will show how the exit works. So the user inserts the booking code he obtained before, and this kiosk shows the duration of the parking and the fee to pay. The data about durations and fees are stored in one of the 2 InfluxDB databases, such that we can compute statistics both for the user in the Telegram bot and both for the parking owner in the web service. Here we prove that after the exit, an MQTT message is sent to the exit class, and the status of the sensor is set again to free from occupied in the device connector JSON. Now we will show the statistics for the user in the Telegram bot, and here the user can see all his transactions through the wallet, and moreover he can see the plots of weekly durations and fees. Then he can also be aware of how much time, money and CO2 emissions is saved thanks to our services, since he doesn't have to waste time to search for an available park in the city. As for the parking statistics, instead, they are accessible only from the parking owner, and you can see how many cars entered in the parking in the last day, in the last week and in the last month, and you can also see the durations and total fees in these intervals of time for all his parkings. In this way you can see which parking has better performances. Then the administrator has also the possibility to access another web page. In this web page we will allow to deactivate some of the sensor, both for reason of maintenance or works or other needs. And if he clicks the button, a command will be sent using REST, and this will allow the state of the sensor to be set to false, so the corresponding sensor will be removed from the catalog.